Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Welcome friends. Welcome to the 30th lecture on the SwayamPrabha course titled Maritime Structures offered by Department of Maritime Engineering at IIT Gandhinagar. This specialized course which has got lot of job opportunities in the maritime sector. Under the given vision of Government of India with blue economy, this is going to boon up lot of employment opportunities and we require a strong capacity building in the maritime sector to make India a stronger nation. Friends, to understand this more with respect to the contents what we discussed in the previous lectures, we will now get into some fabrication and installation processes of couple of platforms which are interesting to learn as well as challenging to comply with. Welcome to the 30th lecture discussing about fabrication and installation of maritime structures. We will take an example of a jacket platform. So, we are talking about an example platform which is a steel jacket platform. We already know jacket structures are bottom founded structures which are used for oil and gas exploration, and they are subset of maritime structures. Bottom supported platforms, as we have learned from the previous lectures, is understood that they are permanent, rigid type, and they are fixed to the seabed using piles, or sometimes they also rest on their own colossal weight. The example could be gravity based structures which rest on their colossal weight. We also know that these kind of structures are uneconomical when they move towards deep water installations because of the substructure cost getting phenomenally increased as you go into deep waters. However, bottom supported platforms are quite successful in operating in shallow and moderate water depths, let us say up to approximately 300 meters. In the previous lectures, friends, you must have learnt how to classify the water depth. It is not a simple number of water depth, it varies on various hydrodynamic characteristics to classify depth as shallow, intermediate, medium, deep and ultra deep waters. We have learned them. I believe that you will refresh them back again to know it more. In the previous lectures of structural action offered by these kind of platforms, we learnt that bottom supported structures essentially resist the load by their strength. So, therefore, the geometry, the member sizing and thickness, the weight and the dimensions of the platform play a very important role in resisting the exciting force acting on the platform, because these platforms essentially resist the lateral loads caused by waves, wind, current and in impact loads essentially by the strength. We also agreed and understood that these platforms have minimum horizontal movement. So, the displacements at the support of these platforms are observed to be very less in comparison to large floating platforms, because floating platforms are essentially compliant in nature. They are designed to remain large float structures, so that they overturn the forces only by the way of large displacement, so that the relative forces between the wave particle and the structural velocity gets altered, and that helps us reduce the encountered force on these kinds of platforms, which we understood clearly from the previous lectures. One important aspect which we must consider in mind before we think about fabrication and installation of bottom supported structures is that they are going to be heavy, they are very massive and they are of larger size. They are required because they are designed to have large deck capacity and designed for long term service life. Approximately the service life of these platforms are said to be 25 to 30 years. So, because of this duration of the tenure staying in marine waters, they are designed to be very strong, as well as they are founded in soil by pile foundations. So, why we are talking about the structural action, the load and size, etc., because when we talk about installation and fabrication, these factors are essentially important to get it in mind. So, let us quickly see some of the photographs of these platforms for recollecting our memory from the previous lectures. One can say that there is a concrete base and the superstructure is a living quarter. You can say this is a crane, the drilling derrick, electromechanical equipments, boat landing, and the colossal weight of the bottom is essentially of concrete. So, one can simulate this to a gravity based structure. Let us look at this. Let us look at the top side again. The top side again has the living quarters, the crane and the drilling derrick, then the system for crane operation, then boat landing and electromechanical equipments. Look at the substructure. The substructure part essentially is of steel and it is a jacket platform. So, we call this assembly as jackets, okay, because they look like a template structure. So, now I want to look both these figures in parallel. Look at the substructure part of both the figures. Here the substructure is essentially concrete, here it is steel. 1. 2. This is gravity based structure and it has got a very huge colossal weight, whereas this is not as massive as the GBS structure. The most important feature which you will now notice and necessary to understand is that these structures are wave transparent. What do you mean by wave transparent? We allow the waves to pass through. When we allow the waves to pass through without any obstruction, the forces exerted by the waves on these members are minimal. But here you can say they form a massive obstruction, therefore, they encounter waves in a larger amount. Okay? So, now one can also notice that the top structure remains more or less similar in both cases, and the top side structure has got different modules. Let us say the living quarter module, the upper deck module, the middle deck module, the landing module and the crane and jackets. These are all different modules which are pre-assembled and brought to site and then assembled here. Okay? So, we do not bring the whole unit as one go. So, we do the substructure separately, the superstructure separately. Even in superstructure, we can also bring these pieces separately depending upon the size and the convenience of their handling as far as crane capacity is concerned. Okay? Now, one interesting part which I can notice, which you will also appreciate, is that being a very large colossal weight at the bottom, if I am able to tow this, because I will not be able to lift it, I can tow this. Generally, these kind of gravity based structures are towed to site and then they are commissioned, whereas these structures cannot be towed as they are vertical, because they do not have that kind of weight which will make them to resist and tow as they move forward. So, these kind of template structures need to be kept on a boat or a barge and they have got to be sailed. So, I can now see another difference. The colossal weight being very large, they can be towed to site and installed, whereas the colossal weight is not that heavy and they are wave transparent, they need to be put on a barge and then floated to site. That becomes another difference. Thirdly, these units are substructure units and these units are superstructure units. So, the assembly is divided into substructure and superstructure and installed separately. Okay? They are installed in modules. Furthermore, even in the superstructure, the living quarter module, the upper deck module, the middle deck module can also be separately commissioned, okay, depending upon the availability of crane and the barge size. Therefore, friends, the installation process which is followed in installing these kind of maritime structures, especially the offshore platforms, vary with different types of platforms. The installation procedure what you follow for a fixed platform is completely different from a floating platform, because floating platforms remains afloat because they are designed to remain positive buoyant. So, one can use simply tugboats and vessels to drag a TLP to site, whereas you cannot do that as far as these are concerned. As far as this is also concerned, you need a big barge where they are placed and the barge is kept afloat to the site. So, the fabrication methods and the installation techniques vary with the different kinds of offshore platforms. This has got to be understood because all of them do not have the same or similar substructure. Furthermore, when the substructure is of steel or is of concrete, when they are designed to be wave transparent or they are not designed to be wave transparent, then the equipments and tools used for fabrication and installation are again going to be different. Okay? And we can now say here the installation methods vary with types of platforms. Okay? That is a very interesting observation which you can also make from the figure. Let us clearly look at an overall view of a jacket structure. We know this is an heli deck, upper side, and these are the main legs of the jacket, One can see the main legs are not vertical, the main legs are vertical, then inclined. There is a taper. This taper is about 1 in 15. Okay, the slope is a gentle slope. So, vertical, then tapered. Obviously, when I look at the water depth of about 300 meters, I cannot have a single member of such a long. The maximum length of the member which can be fabricated and transported cannot exceed 20 meters, is it not? So, I have divided this into meters of 20 meter intervals. So, these are all to be interconnected, welded and joined to become a single column. So, these are all the main column elements. Okay. And you will also see the subsidiary secondary elements, and you will also notice these are the bracings. Okay. The shape being X, they are called X bracing. You can also have different types of bracing, which we will see in detail in the coming lectures. So, these are all the bracings, these are main legs, these are secondary elements. Okay. So, these elements and the fabrication has got to be done with higher quality control in the fabrication yard, because I cannot do the checking of welding, the non-destructive tools evaluation after I install this in C. For example, the water level is somewhere here, okay, this is the water depth, and these are all going to get into the piles. So, I cannot check any of the connections here once they are installed and commissioned, right. So, the entire quality control of this need to be checked in the fabrication yard. It means very simple friends, this has got to be fabricated in the yard in modules and transported and commissioned. Okay. Having said this, let us look at the steps involved in fabricating a jacket platform. Fabrication of a jacket platform has got some few important points to remember. The foremost point, of course, which is very important for a jacket is the material procurement. Okay. Jacket platforms are essentially fabricated using something called marine steel. We have already seen different classification of steel in the previous lectures of this course. So, you would got an idea that what kind of steel is used for maritime construction at this moment. So, we are now going to specifically choose marine steel as the material for jacket, and we need to prepare the jacket using marine steel fabrication. So, we do the assembly of components one by one, then we do the jacket legs and the bracing assembly together. Once they are all arranged, we start welding them. Once the welding is completed, then we install the pile sleeves and boat landings. We will talk about what is a pile sleeve little bit later now. Then for cathodic protection or protecting these steel structures from extensive corrosion in marine environment, we also do something called anode fitting, which is useful for corrosion protection. Friends, in this course we are not talking about corrosion as an important element of discussion. Of course, there are parallel courses of ocean structures and materials which you can learn about the corrosion protection methods which are generally done for steel. Once this is all completed, then we need to take it to the site, because these are all happening in the yard now. I want to take it to the offshore site. So, I do what is called load out preparation. Okay, let us again revisit these points. Choose the material carefully. So, while choosing the material, you must do enough quality checks. You must visit the fabricating yard frequently. You must test the mechanical properties of steel being used for fabrication intermittently, and you should be sure that whatever design parameters you have chosen for the design should be implemented in a true spirit as far as the material properties are concerned. So, a very good quality control on material procurement is necessary. Furthermore, friends, fabrication is a continuous process. Similarly, installation is also, you cannot stop this process once it starts, unless it is demanded by either a local focused accident or because of some weather conditions. So, therefore, friends, apart from procuring the material, you must also have enough quality control and indent for the materials. So, I could now say the important aspects for material could be quantity of the material should be available sufficient. You have to check that in the beginning. You should also do the quality check in the yard for the material property. You should also provide enough indents for procurement of material in advance, so that the work is continuous and is not stopped. Okay. Of course, we need to also look out the power requirements and safety requirements. I mean, without saying why they are not important, we all realize that these are necessary, because our connections are essentially welded connections. We need high power to do this. Okay. Material procurement has got lot of subsets to be controlled. Once I have the material procured, first I will start doing the components. I will assemble the components. We have already seen what are the different components in a jacket structure or a template structure. We take the components, then we pick up the main legs of the jacket and the bracing assembly. We keep on joining them and so on. We do welding. We look into some pictures how welding can be done and how welding can be checked. Then after this is completed, we will do something called pile sleeves, and we also install boat landings, because boat landings are required. You can see in this figure, boat landings are required when you essentially need to park a vessel, a small tugboat, etc. at the level. So, you can see this color of water, I mean the color of steel. This is the high tide level, the water level comes till this point. Okay. So, you can see, I think I can blow it up. You can see the boat landing here. I do not know whether I am able to show you correctly the boat landing. Okay. This is a boat landing. Okay. So, you do the arrangement for boat landing, then you also do some ancillary fittings like anode fittings, corrosion protection methods, and then once these are all done in the yard, keep them ready for something called load out. The word itself is very clear: load disassembly and take it out of the yard to the site. So, this is called load out preparation. Okay. Having said this, let us slightly talk more about the material procurement and preparation. The common cross-sectional shapes used for jacket platforms are tubular steel tubes. We also use plates for the deck, and there are some special components like pile sleeves, conductor guides, and ancillary corrosion protection materials which are used. Let us now see what is a conductor sleeve. Then let us talk about this. Let us talk about what is conductor guide. Friends, conductor guides are specialized components used in offshore drilling. Why they are required? They are required to accurately position and install the well conductors. Well conductors are component of offshore drilling assembly. Furthermore, these guides very necessary when you use large diameter pipes. When you need to drive these pipes into seabed to improve the well stability, we use conductor guides. Okay? So, what is the installation process of conductor guide? One, position the guide in the seabed. 2, drive the conductor in place. 3, use the guide assistance. Okay? Then align and level the conductor. Then secure it properly, that is, fix it properly, and verify or check its integrity. Now, friends, conductor guides are very crucial to ensure precise placement of the conductor. And why do you need this? It is important to ensure wellbore stability, which is necessary for offshore drilling operations. Okay, then the question comes, what are conductor guides? Okay, conductor guides are steel frames. It can be also tubular. It can be also tubular components. They are used in offshore oil and gas production systems to position the drilling rig, to align the rig, and to provide lateral support. The well conductors. So, whenever you have got large pipes to be driven in the seabed, you need conductor guides. Okay, that is a general story we can write. For drilling large pipes into seabed, we require conductor guides. Okay. Now, conductor guides, where are they installed? They are installed at various elevations in the jacket. They also help to withstand lateral forces from waves and wind. Let us see what are the functions of this. What is the function, primary function of a conductor guide? Precise positioning of the conductor, and why it is required? If you want to ensure wellbore stability during drilling, you require this. There are different types of conductor guides. One, they can be rigidly connected to the jacket. Framework. One way is this. They can be also adjustable with legs using bolts. What advantage do you gain by using a conductor guide? It helps to reduce the vibration and lateral movement of the leg. And it also helps reduce the fatigue damage. I mean, it improves fatigue life. What are the various components of your conductor guide? Various components are the guide frame, sometimes polyurethane, centralizers, guide can. Okay. So, conductor guides are useful for precisely achieving the drivability of large diameter piles into seabed, and they are helpful in improving the wellbore stability and integrity of the well subsea systems. Okay. So, we said that conductor guides need to be assembled, and then you also start procuring material for ancillary corrosion protection materials. Once you procure them, verify the grades. You know, steel is graded as grade 1, 2 and 3 as we saw in APRP 2A the previous lectures. So, verify the material grade, you conduct tests on them in the site, in the fabrication yard, and quality check need to be done according to APRP 2A, ASTM and ISO standards. Once you are verified with this, procure them in enough quantity from qualified vendors. Inspect and do quality check at the vendor's works before it is transported to the fabrication yard. Then after the quality check is completed, pack them, mark them and transport them to the fabrication yard. Now maintain a proper receipt with date at the verification for the yard. So, these are all steps involved in material procurement before fabrication, what we prepare for fabrication in the fabrication yard. Once this is done, let us quickly see some of the samples of material which are procured for one such jacket form construction. So, you can see different kinds of rolled steel sections being used, square with uniform thickness with sleeves, circular with mounted caps at the tip. You can see that the tip is larger slightly than the diameter of this, what we call as a mounted caps. You can also have studs which are solid steel pieces of hexagon shape. You can also have these rods which are used to connect the sleeves together and so on. Then you can also have something called pile sleeves. Then the question comes, what are pile sleeves? The pile sleeves are used generally in offshore rigs. They are cylindrical rigs. They are made of high strength steel. They are components attached to the bracket, to the main legs of the jacket. They are helpful in guiding, supporting and securing the steel piles while they are driven into the seabed. Okay. The pile sleeves are typically looking like this. These are pile sleeves. These are pile sleeves. So, they help you to guide the piles while they are driven into seabed. Okay. They are very important. Essentially, when you drive large diameter piles, they are very helpful in case of offshore wind turbines, installation. They are helpful in withstanding lateral loads caused by waves and wind. Let us see a few important functions of pile sleeves. They offer very good structural support to the piles. They are sometimes referred as skirt file sleeves also. They help to improve stability of piles when driven into seabed. The second function what they have is a very good load transfer path. They help in transferring the loads heavy loads, essentially lateral loads, from the piles to soil. Furthermore, these pile sleeves act as interface between the jacket legs and the pile. So, they are very helpful during grouting. There are different types of pile sleeves. One, skirt pile sleeves. These are placed around the outer base the jacket legs. Therefore, they allow multiple legs or multiple pies to be driven in a cluster. The other type is the main leg sleeves. So, in many cases, main legs are directly driven. In that cases, such pile sleeve types are useful. How do you install a pile sleeve? So, there are 3 steps involved. Step number 1, stabbing and driving. Step number 2, grouting. Step number 3, underwater operations. Let us see one by one quickly. In stabbing and driving, once the jacket is in position or jacket leg is placed in position, on the seabed, then piles are lowered. Okay. This process is called stabbing. They are lowered into the sleeves, then driven to required depth using hammers, hydraulic hammers. Okay, that is called stabbing and driving. The next step what we say is grouting. Once the pile is in place, then the gap between the pile and the sleeve is filled. This is an annular space which is grouted, and this will help to create a permanent connection. The third step, in case of deep waters, the connections are made underwater. So, the sleeves actually are submerged at about 20 to 30 meters in water. Let us see what are the components of a pile sleeve, key components. Okay. There are key components like shear key, packers, and guide cones. So, let us see what is the shear key. Shear key is an internal ring which is welded inside the sleeve. And of course, outside the pipe. What is the purpose? It helps increase the strength of the grouted connection. So, that is why it is called shear key. Okay. Packers are inflatable devices which are placed at the bottom of the sleeve they help to seal the annulus. Annulus is the gap between the pile and the sleeve. They help you to seal the annulus, and therefore, it prevents grout from leaking. Guide cones are added to the top of the sleeve. And they help in assisting the pile driving. Now, pile sleeves have got lot of merits. What are the advantages of using a pile sleeve? It improves the durability. So, in case of long term deployment in rough sea, which will last about 50 to 100 years, they help resist loads and reduce corrosion. The second advantage is the installation efficiency increases. because they allow flexible, at the same time strong and precise installation. Friends, pile sleeves are very interestingly important component used in pile driving as we saw, and typical pile sleeve looks like this. Okay, you can see the pile sleeves are attached to all the pipes. Furthermore, we also have some figures and photos of conductor guides, which we already explained what the help of these conductor guides do and why they are useful in guiding them. So, the essential function is to help precise positioning of conductors in the wellbore to improve the wellbore stability. Okay. Having said this, let us move forward to understand the further installation steps involved. So, here are some photos where the quality control check has been done by third parties, like in the fabrication yard, how the deck plates, how the jacket and bracing connections are inspected and checked. So, then the question comes, the jacket leg and brace assembly is again an important component in the assembly. Prepare the assembly bed with precise jig frames. Align the position and the jacket legs accurately as per the layout. Install the primary braces between the legs according to the design and geometry, then carry out welding of the legs as per AWS D11 or APRP 2A. Once the main legs are welded with the braces, then install the secondary braces and other appurtenances such as boat landing, riser guides and conductor guides. Once the whole assembly is completed, perform inspection and quality control at each fabrication stage. Complete the final surface preparation and then apply corrosion protection coating. This is very important. So, this typical figure, one can see how the mud mats, how the main legs, how the bracings are assembled in the fabrication yard, and one can also see how they are checked, lifted, welded and checked using cranes in the fabrication. This is a top view taken of assembly of braces. One can see each brace is assembled separately and then connected. Okay? The whole leg is not, the jacket is not assembled together. Each leg and assembly are separate. Okay? Then they are welded together. Then comes the question of welding. How do you perform welding? Fit up and align the jacket legs and bracings using jigs. Jigs are temporary supports used to hold the legs, because during welding they get warped and twisted. So, you have to hold them tightly. So, jigs are those structural elements which are used in the fabrication yard to hold the legs while welding. One has to perform pre-weld inspection of joint preparation, then the electrode condition, and one has to also do the preheating requirements before welding. We are talking about welding of thick members. The thickness of the member vary from 50 to 75 millimeters. So, thick welding needs preheating. So, one should also check the preheating requirements before welding is done. Then the legs and bracings are welded as per the AWS D11 or APRP 2A standards. One need to follow a controlled welding sequence to minimize distortion. You cannot simply keep on welding to the entire leg, okay, entire leg you cannot. So, one has to do a controlled welding sequence, a controlled welding sequence. For example, if this is the main leg, of one assembly. If you are welding here, one has got to hold both of them with jigs in position, then do welding here and here, then welding here and here. So, one cannot do these two weldings first, then leave it separately. So, one has to be very careful in choosing that you connect one member, so that the alignment is maintained, then connect the next member, okay, and so on. So, the sequence. Once the welding is completed, one need to do post welding cleaning and then inspect the welding connections using ultraviolet methods, then repair if any repair is necessary to be done on the welding connections, then clear the job for final acceptance of load out operation and preparation. Okay. So, a typical photograph during welding is taken. One can see how welding is performed at the pipe connections using seam welding, using high end electrodes, and one can also see the jigs which are placed in position to hold the pipe when welding, and one now can see how the main leg is connected to the bracing and so. So, once the welding is done, this photograph helps you how a non-destructive test evaluation takes place on the welding surface, the penetration of the weld, the run of the weld, the electrode quality, and then the integrity of welding and the alignment of the member. The member has to remain straight while welding, member cannot get warped. So, all these are checked in the fabrication yard, and then the pile sleeve installation takes place. So, the pile sleeve already we discussed in detail about the pile sleeve. Fit up the pile sleeve in position, then do the tack welding first and then the bracing, then you do the full welding of the sleeves as per the approved standards. Then one has to verify the dimensional verification of the sleeve IDs, spacing and the alignment, then conduct NDT inspection, do surface preparation and coat them for anti-corrosive paint before they are load out. The typical pile sleeve welding is the sleeve, okay. Then install appurtenances such as boat landing, position them and align them properly, create temporary supports and do tack welding, then perform full welding, then do NDT checks and final finishing. A typical photograph of boat landing is shown here. These are the boat landings attached to the main leg. The whole assembly is done in dry condition on the fabrication yard, friends. Okay. Then also anode fitting and corrosion protection measures. Prepare the surface of the jacket properly by grinding, cleaning and surface preparation. Fit up the sacrificial anodes position correctly as per the design requirements. Weld the anode pads and brackets properly. Attach the anodes, inspect the welding test and then do apply final coating and touch up and paper ready for load out operations. Now, the load out preparation is almost reached. Verify the load out engineering documents including weight control, center of gravity, skidway design, etc. Prepare the skidways and support structures. Install temporary works such as lifting lugs, padays, etc. Conduct equipment checks, winches, cranes, jack push-up systems, load cells, communication systems. Please inspect all of them. Secure the jacket with C fastening supports. Prepare the pre-load out safety briefing and inspection to the team, and then start using the environmental checks, readiness and final clearance for load out preparation. Friends, this is a very typical jacket assembly completed and ready for load out. Friends, we stop here in this lecture. So, this lecture gave us a summary of what are the various steps involved in fabrication and erection. We have also understood where are various main components, ancillary components, the importance of welding, checking the welding using NDT, and then finally keeping it ready for load out preparation. So, hope friends the sequence make you understand really how intelligently a load out stage is reached from the fabrication yard, where one of the maritime structure application like jacket is ready for load out operation. Hope you will follow this and read more literature parallel to this to understand this further. Should you have any questions, please post them to the discussion forum. Instructors will be able to address your queries and concerns, and do register for these courses and programs at Maritime Engineering Department at IIT Gandhinagar to have a more interesting in-phase and in-place lectures at our campus. Thank you very much. Namaste.